In this video, we are having discussion about the properties of Z transform. The first properties is linearity. You can refer to slide number 22. To understand this property, let's say we have discrete time signal which is x1n is corresponding to the Z transform x1z with ROC equal to R1. While the second signal is x2n is having Z transform equal to x2z with ROC R2. Okay, now we apply scaling property. Multiply the first signal with alpha. So the Z transform for alpha x1n is alpha multiply with the O Z transform x1z. Okay, so alpha multiply with x1z with ROC equal to R1. The second signal, discrete time signal, we do scaling, which is we add on beta multiply x2n. So the Z transform for this signal, beta x2n is equal to beta multiply with the x2z. x2z is come from the Z transform of the all signal. The ROC is R2. Okay, now we add both of the signals to form new discrete time signal. Okay, we perform addition. Alpha x1n come from here plus beta x2n come from this signal. And then Z transform for this new signal is alpha x1z plus beta x2z. Okay, this is the equation for linearity property. Okay, how about the regions of convergence of this new signal and Z transform? Okay, the regions of convergence is greater or equal to R1 intersect with R2. Okay, now we go to example number 1 for linearity property. Okay, actually for this question, the question asks you to find Z transform of this signal. So we have xn equal to 3 delta n plus 4 un. Okay, we know that linearity property, the equation is like this. Xn equal to alpha x1n plus beta x2n. So we need to compare the two signals here. Okay, so we have alpha equal to 3 and beta equal to 4. And then x1n equal to delta n and x2n equal to un. Actually, delta n is impulse. So we need to find Z transform for this x1n and x2n. So for x1n equal to impulse n, which is if we refer to table of Z transform pair, Z transform for impulse is 1. So that's why impulse n is equal to 1 for Z transform. And then we need to find Z transform for x2n, which is unit step function. So x2n equal to un. So refer to table of Z transform pairs. You will get, for un, you will get 1 over 1 minus Z to the power of negative 1. Okay, so the ROC is Z, determinant of Z greater than 1. And then we apply need to apply the Z transform equation, which is alpha x1z plus beta x2z. Alpha, we know that alpha is 3. Okay, so we just substitute alpha and beta into this equation, alpha and beta. So alpha is 3, x1z 1, and then beta is 4, and x2z equal to 1 over 1 minus z to the power of negative 1. So you just need to substitute all of these things and then combine it. 3 multiplied by 1 equal to 3, and 4 multiplied by 1 over 1 minus z to the power of negative 1. You will get this this answer, and then I will show you step by step. Okay, so the first thing, okay, from this equation, okay, you will get something like this: 3 plus 4 over 1 minus 1 over z. So cross multiply this equation, you will get this one. Okay, and then okay, just expand it, and at the end you will get this answer. Okay. Why do we need this answer? Because we need to find the ROC. Okay, we know that z minus 1 equal to 0, and then z equal to 1. But we know that we need to find whether it is greater or less. Okay, because of the signal is at the right hand side. Okay, and okay, so the ROC is greater than 1. Okay, so how do we draw the ROC? This is the Z plane. Draw a circle, and this is at 1 and negative 1. So it is Z greater than 1. So meaning it is outside the circle. Okay, outside the circle, not including unit circle. Okay, unit circle is the meaning of unit circle is Z equal to 1. This is equal is not exist here, just bigger than 1. So it is not including unit circle. Okay, now I will show you example 2 for linearity property. Actually, this example is quite difficult, but I will explain to you. Okay. Okay, given xn signal, which is equal to 1 over 2 to the power of n un plus 2 times negative 1 over 3 n un. Okay, these are unit step function. Okay, so we compare. Okay, we compare with the linearity property equation. So what do we get? Okay, alpha equal to 1 here, and beta equal to 2. Okay, next, x1n equal to 1 over 2 n un. and x2n equal to negative 1 over 3n un. Okay, this. Actually, alpha and beta actually is the scaling number, scale of this signal. Okay, so you need to transform x1n and x2n signal into Z transform. Okay, this is the Z transform pairs. Okay, so this is the formula. A and UN signal, after Z performing Z transformation, Z transform, you will get 1 over 1 minus A Z minus 1, or you will get Z over Z minus A. Okay, next. Okay, we need to transform x1n, which is 1 over 2 to the power of n un. Okay, transform using Z transform. x1z equal to Z over Z minus 1 over 2. So here we know that A is 1 over 2. So just substitute A into this equation or this equation. In this case, I'm using this one. Okay, so Z over Z minus 1 over 2. Okay, so Z minus 1 over 2, we know that Z is greater than 1 over 2. X2n, okay, we have negative 1 over 3 to the power of n un, and then we need to perform Z transform for this signal. So by using these Z transform pairs, you will get Z over Z plus 1 over 3, and the ROC is greater than 1 over 3. Okay, I know that Z plus 1 over 3, like this. Z plus 1 over 3, 3 equal to 0. Z equal to negative 1 over 3. But we know that this is determinant actually. Determinant. So the ROC actually is 1 over 3. Greater because of the signal is at the right sided plane. Okay, so this is greater than. And then we apply linearity property. Okay, this is the linearity property equation. xz equal to alpha x1z plus beta x2z. So just substitute the value here. Alpha is 1, beta is 2. Okay, so alpha is 1, beta is 2. x1z and x2z, you can get it from here. x1z, x2z. And then you just need to simplify it, and you will get this answer. So how do you find the ROC of this Z transform? Okay, we know that this is the ROC of this signal. Z transform is Z bigger than 1 over 2. Okay, for this one, Z bigger than 1 over 3. Okay, so okay, I will draw for you Okay, we have Z plane here with two circles, which is at 1/2 and also 1/3, which is smaller than 1/2. Okay, so now we know that this ROC, this region is greater than 1/2 for this first term. So greater than 1/2. Okay. Okay, just draw it. Okay. And then we know that the second term here, the poles is greater than 1/3. So greater than 1/3 is over here. Okay. Which one is overlap or which one is intersect? Okay. The intersect is when regions of convergence is Z bigger than or equal to 1/2.